for MayaData. I'm here today with Murat, which is our VP product, as well as Uma, which is the Chief Operating Officer for the company. As I said, good morning or good evening. We have folks from all around the world. So let's get started. Today in this session, we will review what's new with the release 1.1, but always in every case, I'd like to take that opportunity to just give a quick refresher to everyone. What is container attached storage and what MayaData offers on that space. We'll also talk about performances and what's coming in the 1.2 release, which is just around the corner. And as always, a quick demo and Q&A session. Right, so container attached storage, just a quick summary. The whole notion of container attached storage is some sort of an answer to what we called, or the so-called cloud native storage. Well, putting the word cloud before traditional storage that lives outside of Kubernetes doesn't make sense, right? There's a lot of cloud washing, and as a matter of fact, that quote from our CEO was chatting with one of our users, saying, "Well, I don't understand why so many people are kind of saying that their storage is cloud native." Well, if you spend the principle behind cloud, the container attached storage, that if you spend time and energy building and developing your applications as a set of microservices, why actually coupling your applications with traditional legacy storage, right? And even if you put the name cloud and say, well, my storage is cloud native, well, if it has not been designed for Kubernetes, if it's not delivered inside of Kubernetes, well, it's not so much cloud native. At least it's not necessarily container attached storage. Next slide. In the concept of container attached storage, well, if you read that slide from the left, you have the option of EBS or network attached storage or traditional storage, where your application is kind of a lock into that specific system, right? You don't have any, you don't have compatible snapshots, and you're locked in one system. Not very agile. In the middle, you have the notion of direct attach or local PV. So same for local storage, where there's no snapshot and you're locked to your existing hardware. With the notion of container attached storage, well, every application gets its own storage controller that is delivered as a set of microservices, and basically it abstracts the storage infrastructure underneath and can be actually deployed on traditional enterprise storage, can be deployed on cloud storage like EBS, and from any provider, but I can also abstract the local resources. If there's no data or storage provider, well, we can create our own. In the case of OpenEBS, well, the folks at MayaData, we started an open source project called OpenEBS that we have donated to the Cloud Native Computing Foundation. And what's unique is that everything happens in user space. You get basically each and every team or each and every DevOps team gets its own storage system. You basically have all the resources that an enterprise storage admin will deliver to you, but you have it specifically cured and tailored for your DevOps, for your software developers. You get a per workload granular management and administration of your storage. Underlying storage could be delivered on any cloud, could be delivered with the local disk or GBODs, and it basically provides a consistent experience for your applications to run and behave the same everywhere. As a company, we built a product or a platform called MayaData Agility Platform, where basically it packages support for OpenEBS, which is basically delivered as an enterprise version, where you get our assistance, up to 24/7 support. You get access to the bugs and actually the fixes for the bugs and the patches before everyone. And more importantly, you also have another project called Litmus that we also started, which helps you validate and harden. Basically, it's a chaos engineering tool for Kubernetes that helps you prove to your enterprise architects, as an example, that Kubernetes is solid enough for those stateful applications to be deployed in production at scale. And basically, the icing on the cake is a big wrapper, which is MayaOnline, that is a monitoring platform for every stateful applications you have in Kubernetes. It is delivered as a SaaS offering, but also as a platform you can deploy in your very own Kubernetes environment on premise, and it gives you a granular view of what's going on in terms of your storage consumption, the performances, the state of the local resources, as well as data migration as a service, which is a nice feature to, based on rules and policies, to migrate your data from one provider to another provider, from one environment to another environment. So basically, we answer the question, where's my data? So you get that view per workload granularity. You can basically harden and prove to everyone that is very resilient to use Kubernetes for those stateful applications, and you can back up and move your applications throughout the whole cycle from your CI/CD pipeline up to your production environment with MayaOnline. All right, now Murat, the floor is yours to give our audience an update on what's on the 1.1 release.
Thank you, Phil, for a great introduction, and good evening, good morning, everyone. My name is Murat Karstoğlu. I'm the VP of Product. Today, I will talk about new features we have introduced with OpenEBS 1.1 release. And then before I get into that, part of CAS architecture and also a bit into performance as well, I would like to talk about the data plane a bit. OpenEBS data plane is responsible for the actual volume I/O. Storage engine implements the actual I/O path in the data plane. And currently, OpenEBS provides 3 storage engines that can be plugged in easily. And in fact, you can even develop your own storage engine if you like. And there are 3 storage engines: Jiva, cStor, and local PV. All current storage engines run completely in Linux user space and are based on microservices architecture. Recently, we clarified that our release gates are defined by OpenEBS Litmus-based GitLab pipelines that run end-to-end tests on multiple platforms and stateful workloads. These pipelines used to catch any regression bugs and also make sure features are compatible with all platforms. A feature is only marked as beta after it's been added to the test pipeline. For example, local PV as of OpenEBS 1.1 is now beta because it is past all these tests and also seeing a lot of production usage as well. Like I mentioned, in terms of performance, so Jiva, you probably, it's the first storage engine we have introduced. It's very well known in the community. And as well as cStor. cStor introduced many new functionalities, more efficient snapshots, and data resiliency functionalities. And also, we are in the process of developing a new storage engines which will improve performance dramatically. But in the meantime, we have introduced local PV, and local PV is similar to Kubernetes local PV, except that it is dynamically provisioned by OpenEBS control plane, just like any other regular PV. OpenEBS local PV also has 2 types inside. You can deploy as a host path local PV or device local PV, and host path local PV prefers to a subdirectory on the host, and device local PV requires a discover disk. All of it that is done through NDM. And many users recently came to the community and start also mentioning why they use local PV, and especially even in production, although it's the latest and the newest storage engine, because it doesn't have a layer between the disk and the data. But at the same time, it doesn't provide a high availability. It is used if your application provides replication and you don't need another layer or storage replication. Again, another feature, as an example of new platform, we have seen quite a bit of usage of especially low print Jiva on ARM, and are now releasing container images built for ARM64 architecture. This is making OpenEBS operational on new Raspberry Pi 4 devices, as well as Amazon A1 instances, which is pretty new, is using custom silicon AWS Graviton processors, and also Pocket's powerful Cavium ThunderX-based ARM compute servers, which are very powerful, comparable to AMD and Intel servers. Provides 96 physical cores and a lot of memory, and that makes OpenEBS functional on other architectures. And before, this is the last slide, before we get into the specifics of the current release, the last 3 OpenEBS releases have set an interesting goal, attaining a monthly release cadence. Before the start of the release, we look at the backlog, which are on GitHub, and items are selected based on contributor availability, and also we try to balance the development of new features, fixing existing bugs, and updating, improving documentation, and as well as hardening the usage of OpenEBS on new platforms. And the list of selected items are tracked for the current release using the using this Google Sheet that I have link here. It's not fancy, but it builds helps to get all the collaborators together. It's used in our community meetings. And the final 2 weeks, as we reach the end of 1 month release cycle, the focus turns to refactoring and adding more test cases while stabilizing the features rather than introducing new ones. And then this process is getting more mature and mature, and we see improvement there as well. And clarity of criteria for alpha and beta. Recently, we also clarified that our release gates are defined by, again, like I said, OpenEBS litmus-based GitLab pipelines. We use these pipelines to catch regressions introduced or bugs. A feature is marked as beta only after it's been added to these tests. And okay, let's get into new features and changes in 1.1. A significant improvement in the upgrade process compared to earlier releases is introduced. Upgrades can be triggered as Kubernetes jobs instead of downloading and executing shell scripts. This is introduced with 1.1, and now upgrades to 1.1 is supported from 1.0. Kubernetes job-based upgrade is a step towards completely automating the upgrades in the upcoming releases. There are some works in the operator part and in other parts to make this more smooth. And also, this is an alpha support for CSI driver with limited functionality for provisioning and deprovisioning of cStor volumes introduced. Once you have OpenEBS installed, you can take it for a spin on your development clusters using the instructions provided in OpenEBS docs. CSI driver also requires a shift in the design of how the configuration of the storage class parameters should be passed on to the drivers. We want to keep this seamless. Please let us know if you have any input and on what you notice as some of the nice to have as we shift towards the CSI driver. There are many enhancements. List is actually longer. You can find the bug list on, again, a release notes page. Prometheus metrics exported by Jiva for identifying whether an iSCSI initiator is connected to Jiva targets, introduced, and enhanced NDM operators capabilities for handling NDM CRDs, installations, and upgrades. Earlier, this process was handled through Maya API server. And also we have done some improvements, enhancement into Valero plugin to take backup based on OpenEBS cast type cStor, and it will skip backup for unsupported volumes. And if you recall, cStor has much more differential and efficient backups, and also enhanced Valero plugin again to allow users to specify a backup path prefix for storing the volume snapshots in custom locations. This is another change. MayaOnline is renamed. It is now called OpenEBS Tractor. And beginning from 1.0, we also have a on-prem version of Tractor, MayaData OpenEBS Tractor on-prem. And if you are interested, MayaOnline adds a really nice functionality on top of OpenEBS. In addition to be able to monitor and manage your OpenEBS volumes, you get nice application dashboard. Applications or stateful workloads running on top of OpenEBS. You can get application-specific dashboards, which gives you volume information, and also you can take granular application again specific snapshots. It's called DMS, Data Migration as a Service on the interface. And volume analytics, as well as special built-in Grafana dashboards for, I believe, now 6 or 7 different workloads, such as Minio, Postgres, and others. You don't need to add or have your instance of Prometheus Grafana. It gives you a managed instance, and comes with built-in dashboards that you can have metrics of your application. And last couple of weeks, we had a handful of new blogs. One is from our CTO, Jeffrey, about the new storage engine. This is gonna be in addition to our storage engines, Jiva, cStor, local PV. It's called MayaStor. It's a code name. It will probably, when it's released, will have a different name, but for now it's a code name. Uses NVMe over Fabric and many other new technologies, SPDK, DPDK, and then to improve the storage performance. Currently it's in a alpha stage. And if you like to test, you can find the instruction from the blog. And also another one, Utkarsh, from Utkarsh, how to monitor OpenEBS cStor pools. That's a nice, very useful blog as well. And then we recently introduced our partnership with Day2IQ, formerly called Mesosphere. And Mesosphere or Day2IQ announced their new Kubernetes solution called Convoy. We certified OpenEBS with Convoy, and you can find the instructions to get it up and running on Convoy in this blog. And also Kiran's release blog gives a detailed information and some background on the process improvements. That's also a nice read. And you can find both all blogs on OpenEBS blogs on blog OpenEBS.io and MayaData blogs and blog MayaData.io. I will pass it to Uma for demo, and thanks.
Thank you, Murat. Uma, the floor is yours. And you can always ask questions while Uma is getting online and unmuting himself. You can always ask questions in the Q&A section, and we will answer questions during the Q&A section of this call or get back to you after this event. Thank you.
Hi, good morning and good afternoon, good evening, everyone on the call. My name is Uma. I'm going to do a quick demo and of a use case that's pretty popular in our community. I would probably need about 10 to 12 minutes as I'm going to really start a new pipeline in the auto DevOps use case. So what we are going to talk is already pretty popular. It's not something new, but it is pretty difficult and interesting to do it in the Kubernetes space. So let's first talk about the challenges with typical DevOps pipelines that we have today. There are two types of challenges that are typically seen where data is involved in Kubernetes. One is, how do we get the latest data onto the cluster that runs CI pipelines, right? And the data always keep changing. It keeps changing because it's in production. You want your code to be tested on a data that is closer to production before putting your code into the production. That means you need to run the pipeline on the latest or closer to the latest data. The second one is developers spend a lot of time in coding, and then when something fails, obviously, it's something that they have not tested using their development test cases, unit testing, integration testing. The pipeline really failed on, most likely it is because it is working on latest data. So we are going to the developers expect the debug environment is given as soon as possible when a test fails. So what I'm going to, before I go to the solutions and how it works, probably I will do a quick code merge, and then we move on to the actual demo, right? So here I have a GitLab environment where I'm going to pick up this and merge this code. Let me resolve this. So as a developer, I'm doing a quick merge, and you will see once the merge is done, you will see a new pipeline getting started. And I will come back to the pipelines. This is the pipeline that's started. So we'll come back to that in about 10-15 minutes because it's a real pipeline. So let's come back to what are the real challenges. So one is about getting the latest data. The second one is about giving the debug environment to the developers with the actual data where the failure has happened. And typically, this takes several days if we have to do it manually, and you need a lot of support from the underlying infrastructure to do these two tasks. So this is a typical DevOps challenge where manual interventions are required. The challenge is build auto DevOps. That's pretty popular among the Kubernetes DevOps practice. So how we solve those two challenges is use OpenEBS cStor and a service called Data Migration as a service to periodically move the seeded data, which is on seed cluster or a staging cluster, to the Kubernetes where CI pipelines are running. That's how you would solve the first challenge. And the second challenge is, again, use cStor snapshots and clones functionality to dynamically spin up an environment, debug environment to the developers whenever there's a failure, right? So cStor provides APIs, YAML declarative APIs to do this, to integrate with your CI infrastructure. It could be GitLab in this case, right? And so typically, if you do those two things, what happens, right? How we do that is you will have a stage cluster which is sitting in the same environment as the production cluster. Of course, you're not going to take a production data and run it on your pipeline. So there will be a massaging of the data, which is usually called seeding of the data, where you take out, as a DevOps SRE or an administrator, you would take out the personal information of your production data and then create a data pattern. This is done by DevOps, and this is pretty straightforward, which is already in practice, right? So what you need to be doing is get this seed data into your CI cluster where your pipelines are running. And how you do that is using DMAS, right? So you go ahead and configure at a particular interval. Probably, your data keeps changing so fast that you want to get your seeded data every week or every day. You can configure your DMAS schedule to do that, and then it comes onto the site. And the second one is whenever a developer merges, the pipeline triggers, and you need to integrate your pipeline scripts. Of course, you would be using OpenEBS here, as it is most easy to use container attached storage on Kubernetes. And then whenever a pipeline fails, you would call the cStor snapshot APIs to spin up a debug environment. And then the developer would usually get a Slack alert or email alert that a pipeline failed, and here is your debug environment that you can access, right? So what I have is an application called MuleShop. It's an e-commerce application, and it is running on Azure, and I have a stage cluster there where there is seed data. And I've set up DMAS, which I'm going to show how it's getting transferred. And then my CI cluster is on a total different cloud, which is generally the case. In a multi-cloud environment, you would have a total different infrastructure set up for your prod versus your dev and CI, etc. And I have a GitLab CI pipeline where I'm running MuleShop. So what I'm going to show right now is I'll just take you through how this entire demo is set up and how this pipelines are running, right? So I will first take, here is the director online, and this is the MultiCloud Dashboard. These clusters that are running on different clouds are connected to this director, which is a SaaS platform. You can also run this in on your own cloud or data center to have, if you're running your environment in an air-gapped environment, you could set up director on your premise. So it's pretty straightforward to get access to director on-prem. So here I have two clusters. This is running in Azure, and this the CI cluster is running on GKE. It's set up across multi-zone. So we have here at the top level of the director interface, the DMAS, data migration as a service. The whole idea is even if your cluster becomes inaccessible for whatever reason, there's a corruption in etcd, and then you lost your data. So you want to be able to browse the metadata of your backups and be able to restore onto a new cluster which is running on the same cloud or elsewhere. So it is possible to set up, access this metadata even when your cluster is down. So I'm going to access a particular MuleShop application. So let me show that MuleShop application, which is in production. So this is a MuleShop application. You can see that there is a cart functionality, and it's really a running application which is on Azure. So here I've set up for one of the databases in that application backups that go every hour, and as you can see, the data that back up and gets transferred to the other side is only the differential data. So it's a pretty efficient process. And then we have transferred one of the snapshot, the seeded data, to the other side, and you could see that the source is on Azure and has been restored to the cluster on Google, and that's really the first challenge that we had, and we solved it this way. And as you can see that the seeded data can keep coming. In this case, I just scheduled it for an hourly basis. And then you could plan the restores also to be done in a similar fashion. So when I view the application, you would actually see that this is going into a different cluster. From the same console, I'm accessing my Kubernetes cluster that's running on a total different cloud, right? It's on GKE, Google Cloud. So here, let me show. So one of the databases that I have, it's automatically moved here, and then I could go and start accessing. So here is that particular database that's running on the other side. Let me show a little bit of bigger overview of what we did. So it actually gives a nice overview of how my particular volume that's running, a volume called catalog DB, has been used on this cluster, right? It's pretty interesting how it happens, right? So this is the original data that is actually received from Azure Cloud onto this Google Cloud. And you will take a snapshot of that. And as you can see that it's been cloned multiple times. If you can see that there are about 7 clones or about 9 clones that have already been done. So when a clone is done is whenever you would start a pipeline. That's how I have set up my GitLab scripts. So whenever a new pipeline starts, I would take a snapshot of my data, the clone of the snapshot, that is the latest seed, and then start running the data on it. So if you can see that in this pipeline, I've taken a clone of that, and it's again cloned because this is a failed pipeline. So on a successful pipeline, you would have cloned the data here, and the data is cloned and the application ran and the pipeline is finished. So this is a successful pipeline. In a failed pipeline, as you could see that the pipeline was cloned from a snapshot, and then again a clone of the state where it failed was taken, and it is given to another environment. So for example, now if you go and see the application where a clone is done, you would see that this is what the user would get. A message saying that something has failed, and we actually instantiated this application out of the data when it failed in the pipeline. And then the developer can get access to that. So this is done in integration to with GitLab, and then you can actually this entire integration is done with OpenEBS CI. This is an open source project where we test OpenEBS builds in open. The pipelines are how the GitLab integration is done. Everything is in open source. You could go to the open source repository of OpenEBS and then take a look at that. For example, I could go and browse all how these pipelines were done and how the integration with GitLab has been done. And the entire thing is an open, how these test cases are written using Litmus and how the CI/YAML files with GitLab is there. So let me go back to, that's an overview of how we do that. So let me come back to what exactly, and I'll show a summary of it. So this is the seed data, and then a snapshot of the data that we received. And for a successful pipeline, you would see cloned data. The tests were run on the cloned data, things were done. But on a failed pipeline, you would again take a snapshot of the data instance and clone it, and this is what given to the developer. So that's pretty much how it's done using cStor snapshot and clone APIs, as well as the DMAS service of the MayaOnline or director, right? So that brings us to the end of my demo. We can probably take some questions.
Thank you, Uma. It's a little bit hard to take the questions. There's no questions in the Q&A that are open. So if you do have questions, you can raise your hand or just type your questions in the Q&A. If you do have questions after, if you're watching the replay of the webinar, you can definitely join us on Slack, and you can definitely also join us via the contact us form on the website. I'll take it from here. Thank you, Uma. Next slide, Murat. All right, so what's coming for you? What's coming in the next release of OpenEBS, Mr. Murat?
Thank you, Uma. And it was a really great representation of snapshots and clones and data abstraction. So what is coming, cooking for 1.2 and after? So we are working on, this is actually, I think, in the master branch, if you want to test, but will be introduced with 1.2, support for cStor volume resize, and as well as cStor pool expansions by adding disks. Using these two functionality, you will be able to dynamically resize your cStor volumes, and also more upgrades, enhancements, and in the cleanup process as well. So this is coming together with operators, and some improvement in NDM, block device UID generation, and more second-day operations into OpenEBS, especially in monitoring health of OpenEBS components. And we have quite a few documentation tasks in the backlog. So one of them will be related to best practices. And as always, you can find the detailed list in public planning sheet, which is shared in OpenEBS repo or OpenEBS website. You can have access to that sheet and add your comments, or always you can add new issues into GitHub, and community is really responsive in a Slack channel. You can also report any improvements or your use cases, so we can improve OpenEBS for your use case. And now, if you do have any question, please ask in the Q&A section.
We'll move on with the get started. So how do you get the ball started, or the ball rolling? Well, to get started, it's pretty easy. First, you must understand what's the difference between the community edition of OpenEBS versus the enterprise platform. A lot of people are asking, well, is OpenEBS Enterprise Platform a closed source version of OpenEBS? Certainly not. So we do not believe in taking an open source software and putting a proprietary software wrapper around it. So OpenEBS Enterprise is 100% open source. The OpenEBS component is 100% open source. What you get is pretty much up to 24 hours, 24/7 support. While on the community version, there's virtually like no support or self-support. You don't have access to the product enhancement and as well as the performance enhancement. So basically, every OpenEBS Enterprise Platform customer gets a couple of hours of our time to fine-tune and adapt the performance based on your specific requirements. You also get access to the patches for the bugs and the updates, which is everything is personalized based on your very own workloads and your very own environment. Important to mention that OpenEBS doesn't have a kernel module, so it runs on any distribution of Kubernetes or any even a DIY or upstream Kubernetes, right? And virtually every Linux operating system, as we do not need to modify the Linux kernel. That said, there's always some rooms for tuning and tweaking some of the parameters. So we are more than happy to support our enterprise customers with that. The Enterprise Edition comes with a greater, full access to the features of MayaOnline, up to 13 months of log retention. As a reminder, MayaOnline is a very advanced logging and monitoring platform for everything related to stateful workloads. It's some sort of a hosted Prometheus with Grafana, Weavescope, all packaged together. It gives you a lot of insights and visibility into your workloads, and it's delivered as a SaaS offering or on-prem. You always have access to a free version, a basic version of MayaOnline that supports up to three nodes. How to get started? Well, there is the starter pack, which is basically it starts at $63 for a kit of 16 cores, or up to 16 cores allocated to OpenEBS, and you get up to 10 hours with the purchase of 3 of those subscriptions, up to 10 hours of our time to help you set up your Kubernetes environment properly and make sure that you are successful deploying your stateful applications on Kubernetes. And also you'll get a very own personalized return on investment document to show you all the savings in terms of storage consumption, especially on public cloud, that you can get by running OpenEBS Enterprise in your environment. Next slide, which is the last slide. How to start? Well, you can go to MayaData.io. You can click on Request Demo. This is definitely the preferred way of engaging with us. You'll need to be enrolled, not in the sales call, but you'll be enrolled in a technical call with the engineers who are involved in the development, and deployment of OpenEBS Enterprise and the OpenEBS community product. So you will have a quick chat about your use cases, and you will get premium support as well as a premium account on MayaOnline, soon to be renamed OpenEBS Director, for the duration of your eval, and our assistance to make sure that you get the most out of your evaluation of our software stack. So we are a team of people highly dedicated to make sure that you are successful deploying, managing stateful applications on Kubernetes, regardless of the size of your environment or the type of use cases you have. So there's no additional questions. I would say it's a first. So it's probably we have a very educated audience today. It's interesting to see that we moved from roughly 30 questions on the last webinar to no questions. So I guess it's very clear. Thanks for joining. The team is always available to answer your questions and support you. Again, thanks for spending 45 minutes with us today.
Thank you, everyone, and the recording will be available after the webinar.
Thank you.
Thank you.